Hi, this is Sajjad, welcoming you to this video of Nuke Learning. In this video, I'm going to share my knowledge about particle system in Nuke. A particle is a dot or a point that exists in the 3D coordinate system. This point has certain attributes attached to it. Typically, they include things like how long the particle has been alive, what size it might be, and what its position and trajectory is. You can include attributes specific to the type of particle simulation you're running, like temperature if you were doing an explosion, or viscosity if you were doing a water splash. The particle system tracks all of the particle information over a set time period and displays that in a way that's interesting. Need to knock up a blood spurt from a gunshot wound or the splash of raindrops on a pond? You can quickly and easily generate these kinds of effects right then and there in Nuke. The use of particle work inside of Nuke is growing, so it's well worth learning how to make the best use of particles across your shots to stand out as a compositing artist who can offer solutions right up to a deadline. Some of the biggest studios in the industry already use the particle system to get a significant speed advantage in their workflows, with decisions increasingly being pushed into comp. Using Nuke's particle system enables you to wait until you know what's required before you invest time into specific elements of a shot. Great when there's no time to go back to the FX department and get a new particle render for a non-hero effect. Creating particle simulations and compositing at the same time means you can set up a scene quickly, look at the context, perform comp work, and then tweak the simulation based on what you're seeing. You can then get immediate feedback for a fast iteration loop. Aside from the obvious use cases like rain and snow, there are a number of other useful applications of the particle system. It can be used for impact hits to create spark hits for laser blasts or gunfire. It's quick and easy to generate sparks that burst out from a specific point. Similarly, it can be used for the embers in fire, cold breath, or dust motes. If you're attaching it to 3D geometry, you can bring in your 3D asset or character and position your emitters so they match the footsteps. To start off, we can use Particle Emitter node. You can hit Tab and type Particle Emitter, or from left side menu, Particles menu, and click on Particle Emitter. This unique and beautiful shape is the sign of particle system nodes in Nuke. Particle Emitter is the only required node for creating particles, but with no geometry input, the normal along which particles travel is the y-axis. Once you've connected a viewer and your geometry, click play on the timeline to see the default set of particles emitting from your geometry. If you look at the properties of this node, you can see there is a lot of information available for you and a lot of things we can define with this node. Let me first go over the options of this node to understand them. This node has three inputs. Particle, the image or geometry to emit as particles. When you connect up this input, another particle input is created, allowing you to mix particle types. Emit, the geometry from which the particles are emitted. Merge, another particle system, including another particle emitter. In the properties we have Start at, sets which frame the particles start emitting. Negative values causes the particles to start before frame 0, and positive values delay the particles. Channels. The particles only exist in the selected channels. Emit from, sets where particles emit from. Point, emit from geometry points. Edges, emit from geometry edges. Faces, emit from geometry faces. Enabling only emit from selected allows you to emit from points selected in a preceding geoselect node. B-box, emit from within the volume, defined by the B-box of the geometry, which can reduce the need for pre-roll. Start at when creating volumetric particle simulations. Emit order sets how particles are emitted. Randomly, particles are emitted from a random point on each face, though the same seed is used each time once generated. Uniformly, particles are emitted from every vertex on every frame, ignoring the emission rate setting. In order, particles are emitted from the vertices of the geometry input. In ascending order, randomized type sets how the initial particle velocity directions are randomized. No random directions are not randomized. The emit object's normals are used to determine directions. Randomized direction, the initial directions are completely randomized. Randomized outwards, a randomly selected direction depending on emit from, B-box, particles move away from the center, points, edges, and faces, particles move away at no more than 90 degrees from the nearest normal. Emission rate sets the exact number of particles emitted per frame and is affected by the rate channel control. Only emit from selected points. When enabled, only points selected in a preceding GeoSelect node are used as emit from sites. Threshold, when only emit from selected is enabled and emit from is set to something other than points. This control indicates the threshold used for selection testing. For example, if set to 0.5, then the boundary is exactly halfway between selected and unselected points. Vertex emission rate, when emit order is set to uniformly, sets the number of particles emitted per vertex per frame. It is an exact number, not an average, and decreases if you change the probability. Rate variation produces a random emission variation by adding a Gaussian distributed random number to the emission rate value multiplied by the rate variation value. Rate channel enables the associated rate channel to the right. Disabling this checkbox is the same as setting the channel to none. Max lifetime sets the number of frames that each particle exists for. Max lifetime range produces a random lifetime variation by adding a Gaussian distributed random number to the max lifetime value multiplied by the max lifetime range value. Lifetime channel enables the associated lifetime channel to the right. Disabling this checkbox is the same as setting the channel to none. Half-life sets a half-life, causing a fraction of the particles to die randomly each frame, such that, on average, half of the particles that existed at a given time will continue to exist after the half-life. Velocity sets the speed in units per frame of the particles as they leave the emitter. Velocity range produces a random velocity variation by adding a Gaussian distributed random number to the velocity value multiplied by the velocity range value. Velocity channel enables the associated velocity channel to the right. Rotation velocity sets how quickly particles spin around their local y-axis in 3D space. Rotation velocity range produces a random rotation velocity by adding a Gaussian distributed random number to the rotation velocity value multiplied by the rotation velocity range value. Rotation velocity channel enables the associated rotation velocity channel to the right. Size sets the size of each particle. If the particle input is geometry, the instance of that geometry at each particle is affected by this value. Size range produces a random variation in particle size by adding a Gaussian distributed random number to the size value multiplied by the size range value. Size channel enables the associated size channel to the right. Disabling this checkbox is the same as setting the channel to none. Mass sets the mass of each particle when a force is applied, for example when using the particle point force node. Mass range produces a random in particle mass by adding a Gaussian distributed random number to the mass value multiplied by the mass range value. Mass channel enables the associated mass channel to the right. Disabling this checkbox is the same as setting the channel to none. Transfer velocity sets the transfer strength of any velocity that the initial emitter had to the particles. Setting this to 0 transfers no velocity to the spawned particles. At value 1, full velocity is transferred from the originating particle. Transfer window sets the time, in frames, to look forward and backward to determine the transfer velocity. Spread applies a spread to the particles, by default a cone shape around the direction of emission. Color sets the initial color of particles when the particle input is not connected. Color from texture. When enabled, the particles take their initial color from the color of the emitter geometry texture. At the point of emission, the color modulates as the texture changes. Region tab sets the region which you want to use to confine the particle effect to. For example, if you choose a sphere, only particles inside that sphere-shaped region will be affected by particle effects.